Hello, we are going to talk about homeostasis and feedback. There's a relationship between the types of feedback and homeostasis, and that's what we're going to go over today. So here are the standards and objectives. Pause and peruse if you'd like. All right, what is homeostasis? Well, homeostasis is a maintenance of a stable internal environment, even when the internal or external environment changes. It's a dynamic equilibrium. That means it's not 100% the same all the time, but as there are adjustments, the body works to bring it back when we're talking about specific types of feedback. Okay, it's dynamic. That means not static. Static would mean it is the same all the time. That's not true in homeostasis. It's dynamic. It has ups and downs, but the idea is to get back to that set point. So what is homeostatic regulation? Well, it refers to adjustments in physiology that I kind of just hinted at that preserve homeostasis. So there's a receptor, that's a big piece of it, and it is sensitive to environmental changes or stimuli. So there's a stimuli in the environment. So for example, the temperature goes up, the temperature goes down, okay? Could be you just ate breakfast. Could be you didn't eat breakfast, okay? Could be you were nervous. All right, whatever the stimuli is. And there's our receptors, and those will vary depending on the stimulus. The receptor is sensitive to that environmental change. And then control center, often the brain, okay, most likely it's going to get its way to the brain. It's going to receive that information from the receptor, process it, okay, and then figure out what to do. Okay, you just ate breakfast. What do I do? What do I do? Okay, you didn't eat breakfast. What do I do? What do I do? Okay, there's something rubbing on your skin. What do I do? Okay, it could be a mosquito just landed on you. Okay, the control center is going to receive and process that information from the receptor and figure out what to do. And then the effector is going to respond to the commands of the control center. Okay, and that either is going to actively oppose or reinforce the stimulus. And that's what we'll talk about when we talk about the two types of feedback. Okay, so we have a stimulus, a receptor, then the control center, decide what to do, and then the effector, the control center has to send a signal to the effector on what to do. So if it was you ate breakfast, it could be the release of insulin, okay, to help bring down your blood sugar. Okay, if you are nervous, okay, you may cause your heart rate to increase. Okay, whatever is happening is going to be in response to that stimulus that was transmitted to the control center via the receptor. Okay, first type of feedback, we're going to talk about negative feedback. Negative feedback serves to correct or counteract the stimulus. Okay, it returns the body to homeostasis. So negative feedback is a return to homeostasis. Usually it ignores minor variations. So if your normal body temperature 98.6 degrees Fahrenheit, your body's not going to react if your temperature is 98.8, okay, or if your temperature is 98.1. Okay, minor variations are going to be ignored usually. It usually maintains a normal range instead of a fixed value. So if 98.6 is normal, your normal range might be from 98 to 99, and your body won't react outside of that range. Okay. Now, different people may have a different, slightly different set point. Not everyone has 98.6 as their normal. For example, mine tends to be a little bit lower, but whatever your normal is, your body will respond when your body gets outside of that normal range. And negative feedback is the most common type of feedback. Okay, if you aren't sure in the test, what kind of feedback is that? You should probably just guess negative feedback because that's the most common. All right, so let's go over thermoregulation, which works via negative feedback. So normal set point, 98.6 degrees Fahrenheit, or in Celsius, that's 37 degrees. If your body detects a high temperature, remember that doesn't mean 98.7, right? But your body detects a high temperature, it's outside of your normal range. What is going to be the response? Well, you're going to sweat. Your blood vessels are going to dilate. Okay, that's going to bring the excess heat closer to the surface of the skin so it can be removed. As that continues, you're going to get back to 98.6 degrees Fahrenheit or 37 degrees Celsius. Negative feedback. High temperature, resolve it through sweating and blood vessels dilating, get back to that normal set point. But what if, on the other hand, what's detected is a low temperature? Well, in this case, you would shiver, your blood vessels would constrict to conserve heat, and then eventually that is going to cause your body temperature to get back to that normal set point again. Either way, the response of the body, the goal in negative feedback, is bring it back to homeostasis, bring it back to that set point, that normal range. Okay, other examples of negative feedback include blood sugar. When you're fasting, it's going to be around 80 to 100. Blood pressure, 120/80. Again, it's a range, right? No doctor is concerned when it's 121/81. Okay, that's not how it works. Blood pH, 7.35 to 7.45. Blood oxygen, 95 to 100. So the idea with negative feedback is maintaining those normal ranges. Now, what about positive feedback? Okay, positive feedback reinforces the stimulus. It moves the body further away from homeostasis. And you might say, why? If homeostasis is maintaining stable conditions, why would I want to move away from homeostasis? Well, it has a specific purpose. It is to regulate a potentially dangerous or stressful process that needs to be completed quickly. So when we go through the examples, you'll see why, okay? So something has to happen fast, okay? And typically it's something dangerous or stressful, but we need to resolve it quickly. So we have to move the body away from homeostasis for a temporary period of time. It is far less common, far, far, far less common. One example is fever, okay? So why would your body start to develop a fever? Well, to kill whatever might be infecting you, whatever bacteria or virus, okay? So the idea is to resolve the issue of an infection, okay, by having a fever temporarily. It's not meant to have a fever forever, just temporary to get rid of the bacteria or virus. Okay, childbirth is an example of positive feedback. So what happens is that as the baby is about to be born, pushes the head against the cervix. The stretching of the cervix causes impulses to go to the brain, and the brain is like, oh, guess what? We need to release oxytocin. Well, oxytocin causes the uterus to contract. Well, when the uterus contracts, it pushes the baby's head against the cervix. When the baby's head pushes against the cervix, nerve impulses go to the brain that's like, oh my goodness, release some oxytocin. When oxytocin gets released, the uterus is contracting. Okay, as the uterus contracts, it pushes the head against the cervix, which again, do you see the cycle? Okay, so more and more oxytocin is going to get released, but not forever. Until when? Until the baby is born. So temporary, to relieve this stressful situation. In this case, it's childbirth. Okay, so the levels of oxytocin are going to rise until after birth. Blood clotting is another example of positive feedback. Potentially dangerous situation. You don't want to bleed to death. Okay, but you also don't normally want your blood to clot, because that can be problematic, right? It can clog a blood vessel, can cause a stroke, can cause a heart attack, a whole bunch of things. But if you're bleeding, if there's a wound, you do want your blood to clot. Okay, so this is temporary, okay, to solve a potentially dangerous situation. So we have, for examples for positive feedback, we have blood clotting, childbirth, fever. Okay, those are the big three. All right, something in the environment, internal or external, that causes a response is what? Do you remember? A stimulus. This type of feedback loop is more common. Do you remember which one is more common? Yep, negative feedback. In positive feedback, the body moves how in relation to homeostasis? Further from, right? It's temporary. In negative feedback, the body moves how in relation to homeostasis? Back toward, right? Okay, so this is an overview of homeostasis and feedback. So just quick recap. Homeostasis, maintaining normal internal stable conditions, even when the environment, either internal or external, changes. So your body temperature tends to remain the same no matter what the outside environment temperature is. There are two types of feedback. We have negative and positive. Negative results in a return to homeostasis. Positive results in a temporary push away from homeostasis to deal with danger or stress. Okay, I hope you learned something new today.